Hey guys, welcome back to Spark AR Scripting. In today's episode, we're going to be covering blur functions, and I'll show you how you can use loops and iteration to greatly reduce the amount of code you need to create complex effects. Right, so let's get started. Once we're in Spark, I'm just going to go ahead and open up our script. I've basically set up a simple screen effect similar to the previous episodes, and all that does is sample the camera texture and outputs it to a rectangle on the screen. And I've covered this in many episodes, so you can check out either the previous or the first episode to see how this works in more detail. Alright, so now instead of just simply sampling the camera image, let's pipe it through a blur function, which is going to sample the camera image, blur it, and then output that to the screen. So let's see how that works. Let's assume we basically have a grid of pixels. So in this case, we have a 3x3 grid. And let's say we're running the pixel shader for the grid in the center. So the way a simple box blur works is basically for every pixel you're operating on, you sample the nearby pixels, and that could be 3x3 or 5x5 or 9x9. In this case, I've highlighted a 3x3 region. So basically, for every pixel, we're going to take the 3x3 neighbors and average them all together. So instead of just sampling the color for the current pixel, first we're going to sample this pixel, which is the top left one. Then we're going to sample the one right above it, then the top right, then the one on the left, then the current one, then the one on the right from here, then this one over here, then this one, and this one. Then what we're going to do is add in all the colors and divide them by the number of pixels we sampled. So that's 1, 2, 3, 4, 5, 6, 7, 9 in this case. So we basically average the color of all the nearby pixel, and that effectively blurs the image because you get a diffusion of all the neighboring pixels instead of just getting a sharp value for each pixel. And what you can do is, firstly, the more samples you add, the clearer the blur is going to be. Then let's say we want to do a 5x5 grid. So basically all we have to do is just add these corners into the mix as well. So then we have 1, 2, 3, 4, 5 pixels over here, and it'll do all these as well. And then if you want 7x7, you basically do the same thing here. And then same for 9x9. And so on. And basically you can make this grid as big or small as you want. And the higher you have it, the more pixels it'll average, and then the smoother the blur is going to be. But it also costs more performance. So the higher you set this, your effect is gonna run slower because for every pixel it has to sample that many more. So let's say we want to do a 3x3 blur. We basically want to, so assuming we start at the center pixel, for every pixel in the pixel shader, we want to go and sample all 3 of the neighboring pixels in each direction. So basically it's a 3x3 grid of pixels. So in total, we're going to sample 9 pixels per fragment. So for this one, first we want to sample this one, then this one, then the one over here, then the one over here, then this one, then this one, then this one, then this one. And if the blur radius was bigger, then we would sample these pixels as well. So one way to do that, and this is probably how you would do it in patches, is to sample each pixel separately, add them together, and then divide the result by the number of pixels. So in this case, in your code or in your patch graph, you would have 9 texture sampler nodes or calls in there. And if we were doing a 9x9 blur, you would have 81 of them. But the advantage of using scripting is, in this case, you can use something called loops. And that basically lets you call the same code on a number of different objects at the same time. So you can iterate through all the pixels in the grid and apply the same operation to them. So in this case, we can start with a value which is 0, then accumulate all the pixels in a loop, and then divide them by the number of pixels. So how does this work? Basically, the syntax for this is to use a for loop. And that basically has 3 parts. There's loop start, then there's the loop condition, and then there's the loop iterator. So what you have to do is, at the start of the loop, you give it a variable. You usually we can just call it I. We can give it the start, and in this case, I starts at 0. then we want to iterate, let's say 10 times. So while I is less than 0, and then every iteration of the loop, we want to increment I by 1. So this is the basic loop. First, it's going to set I to 0. Then every time to the loop, it's going to go and check the condition. If I is less than 0, which is true, then it's going to run whatever's in the loop. And then after doing that, it's going to go and run the iteration step, which in this case, it's going to do I++. And I++ is basically the same as I equals I plus 1. So in this case, let's say we just do something like d.log, and we can do iteration, and then we can add in the current iteration. So now what it's going to do is it's going to keep running this loop until I reaches 10. And then once I equals 10, then this condition is no longer going to be true because I equals 10. And then it'll break out of the loop and come here. So if we save this and go back to Spark, there you go. You can see basically we got 10 iterations of our code. So it starts at 0 and then goes all the way up till 9. And then once it reached 9, it basically incremented the iterator. Then it went back here. I is now 10. So it's going to do 10 less than 10, which is false. Then it breaks out and comes here. So that's the basics of loops. And this is a one-dimensional loop. You can also do a two-dimensional loop. So basically we can do, in this case, we can do j. So let's just reduce this to 3 now. So let's say we do 3 by 3. So we can do j equals 0, j less than 3, j plus plus. Now, what it's going to do is run this in a 2D grid like pattern. So basically what this is going to do is, let's say we do so let's just print it out. So basically what it's going to do is, first it's going to run this loop, and for every iteration of this loop, it's going to run this loop. So when I is equals 0, it's going to run this 3 times. So it's going to do j equals 0, so it's going to run this first with I of 0, j of 0. Then it's going to come back here, increment j, check if it's less than 3, which is true. Then it's going to run it with j equals 0, and I equals 0, and j equals 1. Then it's going to do the same thing again. It's going to do 0, 2. Then it comes here. J is now basically 3. So it's going to break out of this. And then it's going to go here, increment I, then come here again, and start all over again. So in the next pass, it's going to do 1. It's going to do it with 1. And then after that, it's going to come and do it with 2. And then when it reaches here, now I is going to be 3. So it's going to break out of the loop entirely. So if we run this, we should see basically 0, 0, 0, 1, 0, 2, then we get 1, 0, 1, 1, 1, 2, and then we get 2, 0, 2, 1, 2, 2, which is basically a 2D matrix. And there you go. So here we see 0, 0, 0, 1, 0, 2, we see 1, 0, 1, 1, 1, 2, then we see 2, 0, 2, 1, 2, 2. And this is exactly the same pattern we want to sample our 2D grid. Okay, so now what we can do is, let's just move this here into a function called blur. And in this case, what I'm showing you is known as a box blur. So you can basically take this code here, and instead of just printing out a bunch of stuff, it's actually going to sample 9 pixels. And what we can do is pass in, so we're going to need a texture, then we're going to need the UVs, and we're going to need the number of steps. So the number of steps in this case, if we pass in 3, it's going to be a 3 by 3 blur. So if you go back to our diagram, what we want to do is basically start at the center. So if we just keep the loop like this from 0 to 3, it's going to start here and it's going to give us these pixels. But actually we want these ones instead. In this case, what we want is the x to start from -1 and go to 1. And then the y to start from -1 and go to 1. So we want the current pixel, if that's 0, 0, then this is going to be -1, 0. And this is going to be -1, -1 in terms of UV space. So what we want to do is calculate a grid which is centered at the current pixel. So in this case, if our value is 3, then we're stepping 1 in each direction. If our value is 5, then we're going to step 2 in each direction. And if our value was 7, then we were going to step 3 times in each direction. So what we're doing is basically we're taking the radius and then dividing it by 2 and then rounding it down to the nearest integer. So 3 divided by 2 is actually 1.5, but we round it down to 1. And 5 divided by 2 is 2.5, then we round it down to 2. 7 divided by 5 is 3.5, and we round it down to 3, and so on. The way to round down is using a function known as floor, and that's in the math library. So what you can do is create this variable known as iterStep, and that's going to be steps divided by 2, and then you pass it into Math.floor. And that's going to be basically if we log this value out, and then actually let's just call it. So we can do, instead of this, we just call box blur, pass it camera texture, the UVs, and let's just see 3. So now if I save it and go back to Spark, here you basically see 1. Now let's say if we pass in 5, you see 2, and if we pass in 7, you see 3. Okay, so let's just start at 3. So if you're wondering that how we're able to do this divide over here, since we're in reactive code, then the thing to note is basically this code is static. It's something the compiler can resolve at compile time. So the value we're passing in is 3. It's always going to be 3 when you run your script, because it's just that's what we've set here. If you set it to 5, it's always going to be 5. So when it's parsing your script, the Spark compiler, actually the JavaScript compiler, is just going to know that you wanted to do 3 by 2 here, and it'll resolve this at runtime. So by the time it reaches the Spark engine, it already knows that this value is 2. So the Spark engine will see this. It won't even do this divide. And then in here, it'll set up the reactive code for us. And that's something the Spark engine will do. All right, so how do we translate this into our loop for the blur function? So instead of starting at 0, in this case, we want to start at -1 and we want to go to 1. So what we can do is basically just set this to minus iterStep, and this we can set it to iterStep, but instead of less than, we want to set it to less than equal to, because we want to include the step where the value is 1. And then we do the same thing for the j. So we do this, and then this is less than iterStep. So now what it's going to do is going to go from -1 to 1. So it'll do first step, it's going to set this to -1. Then in here, it's going to go I is -1. Then first case, this is also going to be -1. So it'll sample the top left pixel. Then it's going to go -1, 0, because it'll increment j. Then it's going to go -1, 1. So this way, it'll sample the top 3 pixels. Then it's going to go here, set this to 0. And it's going to first go set this. So it'll basically sample the left pixel. Then 0, 0 is going to be the center pixel. And then 0, 1 is going to be the right pixel. Then it's going to go and set this to 1. And what it's going to do is 1 minus 1, it's going to the bottom left pixel. Then it's going to do 1, 0, which is the bottom pixel, and 1, 1, which is the bottom right. So this is actually going to be in terms of UV coordinates. And once I set it up, it'll make more sense. But this is how the loop is operating. Okay. So let's say, so what we want to do is basically for every iteration of the loop, we want to create a pixel vector. So let's just say pixel vec equals r.pack2, and we just pass in the I and the j, which is the stuff I just printed. And what we want to do is move, so if you go back here, what we want to do is move 1 pixel in that direction. So we want to take the pixel vector and multiply it by the size of a pixel. So how do you calculate the size of a pixel? So basically in Spark, we have the canvas object, and I've already calculated it here, which is c.root.find, and you can give it canvas 0. So this is also, the find function is deprecated now, and in the next episode I'll show you how to use promises and use the asynchronous APIs to get this instead, which is the new way of doing things. But anyway, this will give us the canvas object, and then the canvas object has a width and a height variable, and you can find that out by looking at the documentation for the scene module. So if you go to the scene module documentation here, then on the left, these are all the objects it has. So if you click on canvas, it'll basically show you that it has a height and a width over here, which is basically giving you the width and the height in 3D units. So what we can do is, let's say the canvas width is 1280 by 720, then our pixel is going to be 1 divided by that. So 1 over 1280 is going to be the width of a pixel, and 1 divided by 720 is going to be the height of the pixel. So what we can do is basically just 1.0. I'm sorry, so this is in reactive code, so it's going to be r.back2, and it's going to be 1.0. And in this case, we want to do r.div, and in this case, we do canvas dot. So it's width with a lowercase w, and then we do r.div 1.0 by canvas dot height. Now this is basically giving us the width and the height of the pixel. Now what we can do is create a pixel vector, which is this times the width of the pixel. So we basically just do ij multiplied by the pixel width and the height. So now if you take a look at the values we had again, which is -1, then -1, 0, and then -1, 1. If you multiply these values by the pixel width and the height, you're basically gonna step this much in the direction of a pixel, and it'll be the same for these ones. So the center is gonna be 0, 0, so it will just be on our pixel, then here, then here, then here, then here. Okay. So now what we want to do is basically sample all these pixels, accumulate them, and then average the values. So what we can do is over here store a variable which is going to be used to accumulate the color. Let's just call it blend color. We can do Math.floor, and it starts at 0. Actually, this is going to have to be let because we're going to accumulate into it, so it can't be const because we want to change the value. Const is basically you just set it once and you can't change it after that. So now what we can do is sample. If we just do the color for this pixel, it's going to be s.texture sampler, and we pass in the texture, which is passed into the function. And then instead of, so basically our blur UV is going to be, we just add this vector to our UVs, and it's going to take the UV and offset it by the direction we want to step in, and then we just give it the blur UV. So this is basically going to sample all the 9 pixels for us, and instead of storing it here, we can just add it to, so we can do blend color equals r.add, give it blend color, and then add the current sample. So now each iteration of the loop, it's gonna create that pixel vector for us, offset the UVs by it, and then sample that pixel and add it to the blend color. And by the end of it, we're gonna divide that. So basically, we can just do final color equals r.div. It's actually, so it's faster to do a multiply than it is divide. So let's just do num samples equals, basically it's going to be step times 2, step times step. So if it's 3, then we're going to have to do 3 by 3, which is 9 samples. If it's 5, then it's going to be 5 by 5, 25. If it's 7, it's 7 times 7, so 49. So basically what we do is take this, we do 1 divided by this, and then we can multiply it by this value. So what we can do is r.multiply, we take the blend color and we basically multiply it by a value which is the num samples. Then we don't really care about the alpha in this case. That's effectively going to give us the blended color, and we can just return it. So that's basically it. This should actually give us the blur. So if you just go ahead and uncomment this and go back to Spark, so you can't really see it here, but if I set this to 1, then we go back here, there you can see it's a bit more crisp. The thing to note is basically, firstly, the size of the blur, it's controlled by whatever you pass into the function. So in this case, we had done a 3 by 3. But let's say we want to do a 5 by 5 blur. All we have to do is change this value. And then if you go at Spark, you can see it's blurred more. And then if we just set it to 7, it's blurred even more. Then we can go all the way up to 9. Here you go. And you can basically keep changing this as long as you have performance. Basically, you can set this to whatever you want, and the same code works because all it does is increase the size of the iteration value. So the 3x3 is going here, then the 5x5 is going here, and then the 7x7 is going here, and then the 9x9 is going to go. So all we're doing is changing the value we pass in, and that's controlling how far our blur is going. And if you look here, it's basically just 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code. And we can actually just reduce it even more. We can just set this directly here if we wanted to and get rid of these guys, but let's just leave it like this. And you can pack this into here as well, so you can get it down to like 7 lines of code, or even less if you're a bit creative with it, but it doesn't really matter. So the other thing to note is, instead of just going 1 pixel in each direction, we can go more than 1 pixel. So we can pass in a strength value, and we can use that to control how far we go across each direction. So instead of 1 pixel, we can make it go 2 pixels across. And the higher you set this value, the more it'll start to break, because you'll miss pixels in between and it'll start sampling much further than it can. But the thing to note is, you can pass in a value between 0 and 1. So let's say we pass in 1.5 here. So this is 1 pixel. So 1 pixel is going to be here, and 1.5 is going to be somewhere in here. And that lands in the middle of these 4 pixels. So the hardware is actually going to go and average all these together and give you a combined value, and that's known as bilinear filtering. So in effect, by having this value in between 2 pixels, you're getting more blur at no cost to you, because this is built into the hardware anyway. So if you're not sampling the pixel center, if you pass in something here or here or here, it'll calculate where you are in the pixel and give you an average of the nearest pixels for you instead. Okay, so what we can do is just basically multiply these two by the strength, and that's going to be r.mul this with the strength, and the same here, we can do r.mul this with the strength. So if you pass in 2 over here, let's say, so 1 divided by canvas width is going to give you the length of a pixel, and then if you multiply by 2, that's going to be 2 pixels apart. And now what we can do is, instead of 1, we pass in 2, let's say. And if you go back to Spark, you can see it's blurred a lot more. But so just to compare, you can basically set this to 1, see it's less blur, and then if you set it to 1.5, it's more blur, and then if you set it to 2, it's even more blur. And the higher you go, the more it starts breaking apart. So here, see, it's skipping pixels now. So you ideally want it somewhere in between 1 and 2. So just to show you, we can do is just create a curve, and that we can give it like a sine wave based on time.ms, and again we can use our seconds. So multiply this by 0.001, and now this is going to go between -1 and 1. So if we again do the abs, this is going to go between 0 and 1. So then we can do is basically just set that into the curve here. So we just do r.add, and then 1.0 we just add in the curve here. And then if you go back to Spark, yeah, see, now you're getting basically this focus type effect. So you can see it going from 1 to 2, and the strength of the blur increases the further along you go. And to show you, if we multiply this by, let's say, 5, you can see how the value starts breaking if we go higher and higher. See, so that's basically what's happening as you increase this number. Okay, just so you know, if I delete the abs, we'll basically go between 0 and 1. So we'll go between 0 and 2, so it'll give us like this focus effect. So it'll look like it's blurred, and then it'll get back into focus, and it's kind of like you're focusing in and out of the camera using the strength value. Okay, so there you go. That's basically it. We basically did multi-dimensional blur, and it's completely controllable using your script, and you can set the step in the strength value to whatever you want. So you can control the size of the blur and then an additional radius value, which you can either use to optimize the blur or do a more higher level of blur without having more steps in your shader code. And once again, so just to note, so this is known as a box blur. There's actually many different types of blurs. There's box blur, Gaussian blur, and then there's all kinds of advanced blurs. You can do radial blurs, you can do motion blurs. There's many different blurs you can do, and in script you can all of them build upon this. So basically, once you have this, the rest you can take this code and use it to figure out more complicated blurs and a lot of other types of stuff, which depends on sampling multiple different pixels. So there's a lot of stuff you can do with loops in shaders. Okay, so hopefully that made sense. And just to note, there's many ways to optimize this as well. This is like the simplest way to do a blur, just so that I could explain it to you. If you're interested, you can actually look up how to optimize a blur, and you'll find loads of articles which show you how to make this run much faster. And you can actually do it without having to sample a 9x9 grid for each pixel. One way to do that is basically just run a 3x3 grid on your texture and then save it and then run it again. So you can basically stack these blurs. But in Spark, there's no way to do that right now until you have render passes. There's a thing known as shader composition, but all that's going to do is reorder how your code runs. So in effect, you're running the same amount of samples per pixel. So basically, if you use composition to stack blurs together, it's not really going to be faster than doing it in a single loop anyway. And I'll cover that in more detail in a future episode as well. So okay, so hopefully that makes sense. All right, this is a bit tricky to grasp. So if you're confused about something, maybe watch those parts again and actually try typing this out. So it'll be easier for you to understand what's going on. And if there's any questions, just add them to the comments below and I'll get back to you. All right, so thanks again for watching. I hope you learned something. And if you found this video useful, don't forget to hit like and subscribe. And if there's any questions, just let me know in the comments below and I'll get back to you. All right, stay tuned and I'll see you guys next time.